To answer this question, we need to ask ourselves, what are we looking for? So what is the unit that we are looking for? And it is more or less given here. How much ATP would you need? So we are looking for the unit grams. And with this dimensional analysis, we can very easily address this. So we first look for the unit of grams that we have here. Do we have grams somewhere? Yes, we have grams here. So we have 551 grams. So we write that 551 gram per mole. Now the grams is good, we have that, but we want to get rid of the moles. So do we have anywhere moles? Yes, we have moles. It's hidden in here because we can write this as mole per liter. So we can write this as 0.05 mole per liter, and we see the mole down here cancels against this mole, so we have grams left. Now we have got liter here. Do we have any liters? Yes, we've got milliliter, because we can write this as 25 times 10 to the minus 3 liter. So let's do that. 25 times 10 to the minus 3 liters. And now the liters cancel out, and what we've got left is 551 grams times 0.05 times 25 times 10 to the minus 3. And if we put that in the calculator, we get 0.69 gram. To answer this question, we need to identify the type of question that we are dealing with. And here we have a stock solution, and that here is our stock solution here. And when it says stock solution, we need to remember that the equation that we want to use for that is either this C1V1 equals C2V2, or we rather use my mnemonic, where we say basically the doctor says he wants 50 milliliter of a 0.001 molar solution, but the pharmacist says, oh sorry, we only have 0.02 molar solution, and that gives us already the answer. When we put that into the calculator, I forgot the liter here, when we put that into the calculator, we get 2.5 milliliter. To answer this question again, we ask ourselves, what are we looking for? And it's given here. We are looking for the amount of moles. So let's write this unit down. We have moles. Now, first question is, do we have the unit moles anywhere? And yes, it is here. We have, this can be written as moles per liter. So we have 0.04 moles per liter. Now the moles is good, what we have here, but we want to get rid of the liter. So we need to find something that has liter in it, and that is given here. So we can write this 150, that's 15 times 10 to the minus 3 liters. The minus 10 to the minus 3, that is this milli here that we've got from this. So we see the liters cancel out, and the unit that is left is moles, and that is exactly what we want. So it is 0.04 moles times 15 times 10 to the minus 3, And if we put that in the calculator, it gives us 0.0006 moles. Or we can shift the decimal, we can shift it 1 to 3 times, so we would get 0.6 millimoles, or this would be 600 micromoles. So what is what are we looking for in this case? Well, it says what is the molarity of a 9 milligram per milliliter solution. So molarity is given as mole per liter. That is the unit that we want. Now, do we have anywhere where we have mole? Yes, we've got mole here, but it's down here. It's underneath the fraction line. So we have to write it in the way so that mole is on top. So we have mole, and we have 45,000 gram here. Now the mole is good, but we want to get rid of the grams. So do we have anything with grams in it? And the answer is yes, we have grams here. And so we can write 9 times 10 to the minus 3, that's our milligram, in 1 times 10 to the minus 3 liters. That is what's given here. And we see that the grams cancel out, and what we've got left is mole and liter, and that is exactly what we wanted here. So we have to write 9.9 times 10 to the minus 3 mole divided by 45,000 gram, and the 10 to times 1 times 10 to the minus 3 liters. Oh, sorry, the grams have cancelled out. Sorry about that. So we can even get rid of that, and we have 9 over 45,000 mole per liter, and when we put that into the calculator, we get 0.0002 molar, or we can move the decimal and we get 2 times 10 to the minus 4 molar. To answer this question, we are looking for what is the unit that we want. So we have moles here. Let's write this down. So we have the unit moles. That is what we are looking for. Now, do we have the unit moles somewhere? Yes, it is hidden in this capital M, which stands for mole per liter. So we write it that our mole here is on top, and we have 5 times 10 to the minus 5 mole per liter. Now the mole is good, but the liters, we want to get rid of that. Do we have any liters there? Yes, we've got that in here. So we have 8 times 10 to the minus 3 liter. We see the liters cancel out, and we have 5 times 10 to the minus 5 mole times 8 times 10 to the minus 3. And when we put that into the calculator, we get 4 times 10 to the minus 7 mole. So what are we looking for in this question? What is the unit? Well, what is the molarity of this solution? So we use molarity. We are looking for the unit molarity, which would be mole per liter. Now, do we have mole somewhere? Yes, indeed, we have the unit mole, but it's under the fraction line, so we have to write it the other way around. So we have to write mole, and here we have 66,000 grams. Now the mole is good, but we need to get rid of the grams somehow. Do we have grams anywhere? Yes, the answer is yes. We have this 2 milligram per milliliter solution, and we can write this as 2 times 10 to the minus 3 gram, and in 1 milliliter, so that would be 1 times 10 to the minus 3 liters. So the grams cancel out, and we have got 2 times 10 to the minus 3 mole divided by 66,000 times 1 times 10 to the minus 3 liters. Our unit is mole per liter, so that's exactly what we wanted here, so that's quite nice. And when we put that into the calculator, we get 3.03 times 10 to the minus 5 mole per liter, or molar. For this question we are looking again for moles. This one here, so the unit is moles. So do we have anywhere where there is moles in it? Yes, we have this here, because we can write this as 50 times 10 to the minus 6, that is this micro here, micromoles per liter. So that's 50 times 10 to the minus 6 moles per liter. Now the moles is good, but we don't want the liters, so is there anywhere where we have liters in it? Yes, indeed, it's in these 2 milliliters here. So we can write this as 2 times 10 to the minus 3 liters. We see the liters cancel out, and the unit that is left is this mole here. That's exactly what we want. So we have 50 times 10 to the minus 6 mole times 2 times 10 to the minus 3. And when we put that into our calculator, we get 100 times 10 to the minus 9 mole, or we can also write this a little bit nicer. This would be 1 times 10 to the minus 7 mole. Again, in this question we are looking for moles, so we put down the unit moles. Do we have somewhere the unit moles? And actually, no, we don't. But we know from the previous questions, we know that the molecular weight for BSA, for bovine serum albumin, 66,000 gram per mole. So here we have the unit mole again, and we can write this down, mole and 66,000 gram. Now mole is good, but we need to get rid of the gram. Do we have grams anywhere? Yes, we have it here. So we have 500 times 10 to the minus 6 gram in 1 milliliter. So 1 times 10 to the minus 3 liters. Now the grams cancel out, but we still have the liter here. Do we have anything that we can cancel out in terms of liters? Yes, we've got the 3 milliliters, so we have 3 times 10 to the minus 3 liter here, and we see the liters cancel. Oh, the 10 to the minus 3 cancel out here as well. So we have 500 times 10 to the minus 6 times 3 divided by 66,000, and of course we have the unit mole. So if we put that into the calculator, we get 2.27 times 10 to the minus 8 moles.